Yes, students, now let's start with solving question and answers from this particular chapter. So first question is, given this diagram, so hypotenuse has been given and side BC is been given. You have to find out what is the side of AB. Also, you have to find out what is going to be sine A into cos C. See, if you can observe, you just have to have a look at this angles, that is sine A is what they have asked and cos C is what they have asked. First let's find out what is going to be AB. See, it is very simple. You can use this Pythagoras theorem, that is AC square is equal to AB square plus BC square. Once you add on the values for everything, you will be getting the value of AC, and the value of AC I've got is going to be 25 centimeter. Once I've got that, sine A is what I have to find out. So if my theta is over here, it is going to be opposite divided by hypotenuse, right? Sine A is going to be opposite divided by hypotenuse. So over here from angle, opposite is going to be BC divided by AC. So BC by AC is going to be 24 divided by 7. Right. The next thing is what is cos C. If my angle is over here rather than over here, if my angle is at C, then cos C is going to be adjacent divided by hypotenuse. Again, adjacent is going to be 24 divided by 7, and finally you just have to multiply. So over here it is going to be 24 by 7. So just multiply 24 by 7, the whole square is what you'll be getting the answer. Clear? Next question. If sine A is going to be 3 upon 4, cos A is going to be you have to find out what is cos A and tan A. First and foremost, when you consider the triangle, they have given you sine A. So sine A is nothing but, see, if your angle is at theta, it is going to be opposite divided by hypotenuse. So 3 and 4 you have. So AB is what you need to find out, right? So first again, as usual, apply Pythagoras theorem. You'll be getting the value of AB. Once you get the value of AB, they have asked you to find out cos A and tan A. So cos A and tan A, just apply the formula. It is going to be adjacent by hypotenuse, which is going to be root 7 upon 4. And if you divide sine A by cos A, you will be getting tan A, which is going to be 3 divided by root 7. Clear? Next question, if angle A and angle B are acute angles such that cos A is equal to cos B, you have to show that angle A is equal to angle B. Right. First, cos A is going to be in terms of triangle, that is formula wise. If I have to write this, I can write it as AC upon AB, and for cos B I can write it as BC upon AB. Once I write that, I have said that cos A is equal to cos B. Whatever I have got over here, I am just going to equate it. Once I equate it, see, in the denominator AB and AB gets cancelled. AC is equal to BC is what is left out. Right, if AC is equal to BC, we can easily tell that angle A is equal to angle B. But why? See, angles opposite to equal sides are always equal. AC is equal to BC, right? AC is equal to BC. If these two are sides are equal, then angles opposite to equal sides are always going to be equal. Clear? Next question. Evaluate the following. So over here, sine 18 degree divided by cos 72 degree is what you have. So you have learned this complementary angles. So sine 90 minus 72 is what I can rewrite that, and cos I will write it in the same manner. Right. See, if sine 90 degree minus 72 degree is there, the formula is going to be, see over here, first let's just have a look at it once again. Sine 90 minus theta, it is going to have cos theta. So over there I have sine 90 minus 72 degree. This is what I have. So it will be having a place of cos 72 degree. Right. So this is what we will be using our application. So cos 72 degree, and since I have kept my denominator same, if I just cancel both, it is going to be equal to 1. Similarly, tan can be written in terms of cot. Right. See, tan 90 minus 64 degree, wherein even the denominator I have cot 64 degree. So even over here also, both of it, numerator and denominator, is going to be equal, and is equal to 1 is what I'll be getting. The next question, if tan 2a is equal to cot a minus 18, where 2a is acute angle, a is equal to question mark. Right, this question has been quite repeated, so just have a look at it. So given is tan 2a is equal to cot a minus 18. So tan 2a can be written as cot 90 minus 2a. Right, and this I'll just write it in the same manner. So cot and cotter I can just write it 90 minus 2a is equal to a minus 18 degree. Just rearrange the terms, you'll be getting the value of a. All that you have to do is this one step, and rest everything you can manage. Next question. Express sine 67 degree plus cos 75 degree in terms of trigonometric ratios, angles between 0 degree and 45 degree. Right. See, in this particular question, sine 67 and cos 75 is what is being given. So they have just said you within 0 degree and 45 degree. So if I just deduct this, this is going to have a place of cos 23 degree. And over here it is going to have a place of sine 15 degree. And this is your answer. Right. Next question. You just have to evaluate the question as well over here. Over here, whenever I have this type of question, what is it first I will aim for? See, I will see that my both numerator and denominator is going to have something similar values. Right. So for that, again, the same application formulas I'll be using. Sine of 90 degree minus theta is going to be equal to cos theta. Similarly goes for the next one. So keeping one as same, I'll just change another one. Similarly, keeping one as same, I'll change the other one. So when I'm doing that, I'll be getting sine square 63 plus cos square 63 divided by sine square 73 plus cos square 73 degree. Right, this is what I'll be getting. But for this, if you can observe numerator separately and denominator separately, it is in the format of sine square theta plus cos square theta. So sine square theta, anything, it is equal to 1. Therefore, 1 upon 1 is going to be equal to 1. Next question, if 3 times of cot A is equal to 4, you have to prove that 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sine square A. Right. So first they have given you the information of cot A is equal to 4 upon 3. So when I'm just having my value over here, it is going to have a place of 4 in AB and 3 at BC. Right. So now let me consider this AB to be equal to 4k and BC to be equal to 3k. Even if you don't consider also, still you'll be getting the answer, but still it becomes easy for you if you just understand it in this way. If you apply Pythagoras theorem, you have to get the value of AC. Right, suppose if you hadn't considered k, it is going to be 4, 3 and over here you'll be getting 5. Right. Next, tan A is equal to BC divided by AB. What is the only difference in taking the k? See, over here also 3k divided by 4k I'll get. So k and k gets cancelled. Eventually I'll be ending with answer 3 upon 4. Either you use k or even if you don't use also, you'll be getting the same answer. So over here you have to prove this. For that I have to get my tan A. So to tan A, the value of cot is going to be 3 upon 4. See, even like that also, without considering all this Pythagoras theorem, straight away they have given you cot A. That is 4 upon 3. So tan A is going to be just the reverse of cot A. So you can just go ahead and write tan A is going to be equal to 3 upon 4. Right, but still I just have to solve using Pythagoras theorem because in the question I have cos A, cos square A and sine square A is also I have to find. But first, considering my left hand side, 1 minus whatever I have got. See, 3 upon 4 is what I get. So when I square it, I'll be getting 9 upon 16. So consider LCM. So finally, you'll be getting 7 upon 25. So the next right hand side, this question is something, prove that, right? So left hand side, we have got something like 7 upon 25. So right hand side, I have this cos square A minus sine square A. But I don't know the value of cos A also as well as sin A as well. So cos A, if you can observe, so cos A is nothing but adjacent divided by hypotenuse. It is nothing but 4 upon 5. Right. Similarly, 4 upon 5 is going to be a cos A. Opposite divided by hypotenuse is going to be 3 upon 5. Once you get the values, you just have to square both of it and just deduct it. Right. So first 4 upon 5 the whole square minus 3 upon 5 the whole square. First elaborate it, you'll be getting 16 upon 25 minus 9 upon 25. It is like terms, the denominator is like. So you'll be getting 7 upon 25. Even in LHS also you got 7 upon 25. On right hand side also you've got 7 upon 25. Hence you can finally write that statement, whatever they had asked you in left hand side is equal to right hand side. Right. Next question. Express sine A, secant A and tan A in terms of cot A. All these three you just have to express in terms of cot A. Right. First, before just jumping, see tan A is just the reverse of it. Right. Secant A you have a formula related, and even sine A also can be used. First, sine A, considering sine A using the identity. You have this identity wherein cosecant square minus cot square A is equal to 1. See, this cosecant square is nothing but equal to 1 divided by, it is reciprocal of sine square A. Right. So 1 divided by sine square A is equal to, shifting everything towards my right hand side. So 1 divided by sine square A, see over here if I just shift it to the other side, it will become 1 divided by cot square A. Right, they had asked you to find out just cot A. So in terms of whatever the sine A is there, you have to find it out in terms of cot A. See, throughout the question I've got it in terms of square, because the identity which I have used is going to be in the terms of A square. But to remove the square, I just have to shift this towards my right hand side, which gets me root. Right, root 1 is going to be 1 only, divided by within the root 1 plus cot square A. This is what I'll be getting for sine A. See, this is in terms of cot only. Now, the next thing is going to be in terms of sine secant A, also have to show it in terms of cot A. So this is going to be very simple. You have direct formula wherein secant square minus tan square A is equal to 1. See, again over here also tan square can be written as the reversal of cot square A, that is 1 divided by cot square A. And again now secant square is what is left out. But here if you can observe, you have to consider LCM. So when you consider LCM, it is going to be cot square A plus 1 divided by cot square A. So here you had secant square A. So when I have to remove the square, it is going to become a square root. So when I remove square root over here also, square and root gets cancelled. So in the denominator you will be having only cot A. Right. So the last thing was tan you have to represent in cot A format. So tan A is just simple of reversal of cot A. Right. This was something exclusively for this particular chapter. So we have covered quite a unique questions in this chapter. So I hope this video has to be helpful for you. Thank you, students.